Okay, so we want to solve this equation here. X squared minus 6x plus 5 over x squared minus 2x minus 3 equals 2 minus 3x over x squared plus 3x plus 3. So first, I'll just copy the equations as is. So solving equations, as I said yesterday, can you cross multiply? Yes, you can, right? Yeah. Not for inequality. So we're just going to multiply both sides by x squared plus 3x plus 3 to eliminate this, right? And also by x squared minus 2x minus 3 to eliminate this. That's basically what cross multiplying is, right? So now the left side is x squared plus 3x plus 3 equals, and the right side is 2 minus 3x. Oops. I've got to multiply this by x squared minus 6x plus 5. And then the right side is 2 minus 3x times x squared minus 2x minus 3. Then it really is just a polynomial equation. So the left side is, I have x to the fourth plus 3x cubed plus 3x squared minus 6x cubed minus 18x squared minus 18x plus 5x squared plus 15x plus 15 equals 2x squared minus 4x minus 6 minus 3x cubed plus 6x squared plus 9x. So simplifying that gives us this fourth degree polynomial function in standard form. Yeah. All right. Okay. Okay. And then how do you solve this? Polynomial equation, right? Let f of x be x to the fourth minus 18x squared minus 8x plus 21. I'm jogging your memory now about solving polynomial equation. What theorem do you use? What theorem do you use? The factor theorem, right? You have to find a zero or x to the fourth minus 18x squared minus 8x plus 21. You used a rational zero theorem, right? RZT. So dot 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 DIY. You know what to do. So this I don't think this has a rational, like has a solution that's rational. Okay, so if there isn't, right, if you cannot come up with a fact like a zero for this, right, using the rational zero theorem and the factor theorem, that means you're not going to be able to solve this, right? You have to solve it graphically, right? Yep.
Can't you also like factor the initial polynomials?
Yes.
Like when the 11?
Yeah, you could, and then you could cancel, right? So what you're trying to say? Yes, but there was no. You could try to simplify this, right? But there are no common factors. Okay. So this one, I believe, does not have a rational solution. Yep. Yep. So where can you find more practice? So textbook has a lot of practice questions, right? So if you go to let me share screen. Go to the textbook. See, the question that I just did is number 15. So in the context of a word problem, you might get something like question number 16, right? Objects A and B move along a straight line. Their positions S with respect to the origin at t seconds are modeled by the following functions. Object A, the position function is S of t equals 70 over t squared plus 1. The position function for object B is S of t equals t plus 5 over t plus 2. When are the objects at the same position? How does this manifest itself mathematically? For A, when are the objects at the same position? You said, yeah, so at the same position, right? S of t for object A equals S of t of object B, right? So this equals this, right? And then you solve. For question B, part B, when is object A closer to the origin than object B? So I want you to think about that. Closer to.
Closer to mean less time traveled away.
Closer to the origin. So I want you to think about that. We'll take this up tomorrow. So I want you to think about that. Okay. Now let's do a inequality question. This is also from the textbook, page 296. Six A. So solve x plus 3 over x minus 4 is greater than or equal to x minus 1 over x plus 6. So for inequality, are you allowed to, quote unquote, cross multiply? No. Okay. So what do you have to do? You have to, basically make it a standard form, right? Standard form by using addition or subtraction. So give it a try, and get to the state where it's sort of like a standard form, meaning one side of the inequality is 0 and the other is a rational expression. Okay, so we always start by writing the equation as is. as I said, right, you cannot cross multiply, because if you cross multiply in an inequality, you have to be sure that whatever you're multiplying to both sides is either positive or negative, right? The reason being, if you multiply an inequality by a negative entity, what happens to the sign of the inequality sign? It would flip, right? So since x can be, in this case, x can be any values, but that can render x minus 4 or x plus 6 positive, either positive or negative, you cannot multiply both sides by term involving x. And of course, make sure you always put down the restriction based on this. So x cannot equal to negative 6 or 4, right? So it doesn't hurt. Put down the restriction. So here, what I can do is I can subtract the term on the left side by itself, right? Which is x minus 1 over x plus 6. So x plus 3 over x minus 4 minus x minus 1 over x plus 6 is greater than or equal to, this will be 0. Okay. So the right side, the left side is a rational, it's two terms, right? So you have to make sure that it becomes a single term, single rational expression before you do anything else. So what do? I just consolidate these two fractions. I can multiply the first fraction by x plus 6 and divide by x plus 6. And then the second fraction by x minus 4, x minus 4. So the inequality now is x plus 6, x plus 3, take away x minus 1 times x minus 4, the whole thing over x plus 6 times x minus 4. The inequality sign stays. So now I can simplify the numerator. In fact, this is not the end, so I shouldn't put a period there. So distributing and simplifying the numerator gives us 14x plus 14 over x minus 4, x plus 6 is greater than or equal to 0. And the numerator can be simplified to that. Okay. Now we are in the position of able to move on to the next step, which is the number line step. So to do that, it's always easy to write the non-zero side in function notation. So let f of x be 14 x plus 1 over x minus 4 times x plus 6. Okay, so picture this rational function here, f of x. It's quite a simplistic rational function. When you're solving inequality, we really are only interested in the x-intercept, f of polynomial. But in rational function, we also have to deal with vertical asymptotes. Those are the only two things that you have to deal with. So the x-intercept for f of x is what? What's the x-intercept? How many x-intercepts are there? 1, right? X equals -1. Right? And the vertical asymptotes two of them are x equals -6 and x equals 4. Using the number line chart, we have that. So just like the number line method for solving polynomial inequality, you construct a chart with with all of these factors, right? The numerator as well as the denominator on the in the first column. So I have all of them. So 14 is a factor. X plus 1 is a factor. X minus 4 is a factor, and x plus 6 is the other factor. It's another factor. And this is where we put down the number line. So 14 doesn't have a 0. So the 0 for x plus 1 is -1. The 0 for x plus 6 is -6. Okay. Note that this is a what? It's a horizontal asymptote. I would use an open circle so that you're not inclined to include it. You're solving for an inequality involving equals, right? Greater than or equal or less than or equal. And I like to use dash lines to remind me that this is a VA. Okay. The next number to the right of -6 is -1. Is this a vertical asymptote or is this a x-intercept? This is an x-intercept. I can use solid line. And then the final 0 is 4. Is this a vertical asymptote or is this a x-intercept? The VA, right? So I use open circle and I use dash line. So now it's just the same procedure, right? So think of a number in this region, -6 or less. 14 is always positive, right? Positive. In fact, we can just put down 14 is always positive. X plus 1. If x is less than -6, x plus 1 will be positive or negative? It will be negative, right? Think of a number, -100. X minus 4 would also be negative, and x plus 6 would also be negative. Between -6 and -1, let's say -2, x plus 1 will be negative, x minus 4 will be negative, x plus 6 will be positive. Between -4 and 1, let's say 0, x plus 1 will be positive, x minus 4 would be negative, x plus 6 will be positive. Greater than 4, this will be positive, positive, and positive. So the net result for each of these regions is, okay, so when x is less than -6, this region, the graph is negative, right? You multiply a negative by a negative by a negative, it's a negative. Between -6 and -1, it's positive. You multiply negative by negative is positive, right? Between -4 and 4, it's negative. Greater than 4, it's positive. Now we're ready to list our solution. So we are trying to identify the region where f of x is greater than or equal to 0. So it's this. And it's this. How do we represent these intervals? Solution to the inequality, I will present both the solution both in interval format as well as set format. So interval format is what? So this region is what? -6, -1. Okay, so I know we're solving for this inequality involving greater than or equal. Do we include -6? No, right? Why not? It's a BA, right? So the graph never crosses the BA. At -1, do we include or do we not include? We include, right? Because this is a x-intercept, right? And we are solving for the value of x when f of x is 0. And that's exactly the x value when f of x is 0. Okay, so we're done with that. Don't forget the union notation. Now in this region, we have 4 and going to infinity. Do we use square bracket or curve bracket? Curve, right? So it's open. Why is it open? Because this is also a BA. And infinity. Close or open? Infinity is always open, right? Yeah. So this is it. Or in set notation, this is represented as -6 is less than x is less than or equal to -1, or, right? Union means or. Okay? X is greater than 4 as required.